Thanks. All right, I'm Katherine, and I'm going to tell you a story about the care and feeding of monitoring. And it starts, like so many of our stories, with our good friend PagerDuty telling us that our site was down. And like reasonable people, we decided to check and make sure that the site was down before we panicked, and we did, and the site was down. So we started looking into this, and then it came back, like a minute later. And we said, what the hell just happened? That was weird. And so we waited and we looked and everything seemed fine. So we said, okay, everything's fine. Nothing's broken. Let's just go about our business, go have some office beers, whatever it is that we're doing. A few hours later, PagerDuty again, saying, oh yeah, by the way, site's still down, stuff's still broken. And once again, like a minute later, with no explanation, it comes back. And at this point we said, well shit, something's obviously wrong, we should probably look into it. And we called it the blip. And this happened a few times a day, sometimes only a few times a week, but it just kept happening seemingly at random. We couldn't find anything that was wrong. I mean, we could still watch Netflix, so Amazon seemed to be up. Nobody had deployed anything that was weird and had some if statement with a math.random take down the site. So we decided to look at some of our favorite graphs. Web 500 errors. None, no errors, it's fine. We looked at our web servers and our API servers, breaking them down by server, because we'd seen in the past sometimes a couple servers will just decide that they don't like serving anymore, and they'll take down the site temporarily when stuff's getting routed to them. But it wasn't that. Looked at API error rate, and everything seemed fine. All of our Mongos were up and Mongoing. We couldn't find anything that was wrong, so what was the missing piece in our monitoring? Because something was obviously going wrong, the site was going down, that's bad. But our monitoring wasn't telling us what. So what could we do about this? You might say, monitor all the things, because obviously, we're missing something. Just monitor everything, and one of those things will tell us what's going wrong. But then you just end up with this. This is one of my favorite friends, Xenos, which I don't have to deal with anymore, but if you monitor everything, probably you're gonna find a lot of things that, yeah, they might be wrong, they might not actually be wrong, but they're probably not the things that you were trying to find. If you're looking for a needle in a haystack, the answer is not to add more hay. It's, doctors say that full body scans are not a good diagnostic tool, because if you look at, a perfectly healthy person or a perfectly healthy computer system, you're gonna find a few things that look wrong. And, maybe if you monitor everything, you'll find some things that are actually issues that these things are good to find, it's good to fix them, but they're probably less important. When you have something that's, this high priority, like the whole site going down, maybe you should be focusing on that. So monitor some of the things. Well, yes, thank you. That's very helpful. If we knew which things we were supposed to be monitoring, we would be monitoring those some things already. So maybe we'll just eliminate some of the things that we know that it's not. So this is the story of our sad server. It's on fire, it's not doing so well. The first thing we looked at was our load balancers in Amazon, in the cloud, because we noticed that when stuff went wrong, all the servers just fell out of the load balancer. And we talked to Amazon Support and they said, you should replace the load balancer, because it's in the cloud and it rains in the cloud and it got rusty and you need a new one. Just replace it. So we did. They said the same thing about the servers. We replaced those. It kept happening. We switched availability zones. We tried a whole bunch of different things, and they were convinced that it was probably the ELB somehow. And coincidentally, around this time, Amazon introduced their access logs for the ELBs. And we looked at those, and we finally came to the conclusion that it wasn't the ELBs. So the health checks on these ELBs, those are what determined if the nodes are healthy enough to be in the load balancer and to get traffic. Our health checks for these API servers were talking to a service that we wrote called Healthy. And Healthy was designed to monitor these two API systems that we had, cleverly named API 1 and API 2. And it was supposed to say, okay, they're both healthy if they were both healthy, and if one of them went down, it would say, no, no, that's bad, kick it out of the ELB, we don't want that. So we said, yeah, okay. The Healthy is saying that these things are wrong, so why? Oh yeah, we forgot to add any logging to that particular service, so it wasn't telling us anything at all. Which might surprise you to hear this, but that isn't actually very helpful. If we didn't need any more detail on what was actually going wrong in particular, we could just have Pingdom tell us, oh yeah, the site's down, and we could quit writing all of these awesome tools that we're working on. But we actually need, more detail than that. So the first step that we took was to add logging into this Healthy, and then it actually told us something helpful, like which API was going wrong, or maybe it was lying to us and everything was fine. As it turns out, one of the APIs was fine, and the other one did actually have a problem. So finally we knew, here's probably where the issue is. This seems like it might be our missing piece. And now, if we start doing our computering, we have a reasonable expectation that we're looking in probably close to the right place. We also had some people do the whole monitor all the things, just throw monitoring against the wall and see what sticks. The only thing that they found was a strange user who had started to figure out how to script our site, which is weird because our users are largely non-technical. They write emails to us in all caps when they're angry. So they didn't actually find anything helpful. But now that we knew it's probably in this API 2, we can add some more monitoring there. So we went into our API middleware and we added some metrics. Everyone loves metrics. We went in and said, okay, for every API handler, what's the response time, and how much time is the request spending doing actual work versus, sitting and waiting for the database or waiting for some third-party API to respond. And once we had these metrics, we could have graphs. Everyone loves graphs. So this was a graph of all of our different individual API handlers, their response times. Most of them, right along the bottom, were very, very good. They responded right away. A few of them, probably we had 5 to 10 when we started, were taking a lot longer to respond. And we zoomed out further, and this is over the course of about 3 weeks. Each of those spikes was a blip when the site just completely fell offline, because those response times just got so high on these few API requests, and yeah, we didn't really know why. But we can go in now and give our story a happy ending, and now that we know, our monitoring is telling us these particular handlers are screwing up and doing something wrong, we can fix them. So we made some of them time out. I mentioned that the site would go down for a minute each time that this blip happened, and several of the handlers were set to time out after a minute, but none of them were actually doing anything useful for the majority of that minute, so we set the timeouts lower, something like 5 seconds that won't kill the site so much. We found some database queries that needed to be optimized. We resharded some of our collections, rubbed some web scale sauce on it. And some API methods were old and shitty, and we just deleted them because we didn't need them anyway. And at the end of it, these servers were only a little bit on fire, and the site stopped blipping up and down. But the question is, how did we get to this place where our monitoring wasn't telling us anything useful, or in some cases it wasn't telling us anything at all? We thought we cared about monitoring, so how did this happen? We didn't consider the effects of black boxes, not black boxes in the cool things that live in airplanes, but black boxes in that black box testing, you put something in, something comes out, but you don't have any idea what's going on inside of it. This could be like our service that we wrote where we just decided that we didn't need to know any more details. Could be stuff in the cloud, stuff in Amazon, anything as a service. These things that other people control, that other people maintain, they're doing the monitoring of these services, and if you're lucky, they'll give you a status page saying, hey, our API is responding fine, or no, response time's not so great right now. But you don't have necessarily the same visibility that you would if you were doing everything in-house. Which isn't to say that you shouldn't use these external services, but just consider that you won't have the same visibility, and if something goes wrong in one of those things, you're going to be dependent on somebody else's monitoring to figure out what's really going wrong. We also have the question of, okay, why do we have these two different API services on the same server, and why are you not monitoring them well? Who thought that was a good idea? That's an excellent question. So nobody set out in our company to make these bad decisions. Like, nobody said, you know what I really want to do today? I want to screw over the future ops team. I'm just going to make this terrible. Now, what it started out was some developer got the bright idea of, I hate this API, I'm going to rewrite it from scratch, because that always works out well. It's going to be the new hotness, it's going to be amazing. People were on board and they started doing that, but as happens, computers get complicated, things don't go quite the way you intended, business, real life stuff gets in the way. And we got about halfway through when we realized that it wasn't going to happen. But by that point, it was too late to back out, and we were stuck with these two APIs. And for reasons that nobody understands, instead of splitting them up into separate servers, they stayed on the same server. If we had a time machine, we could go back and ask them, what were you thinking? But if we had a time machine, we could just go back and not do this whole thing in the first place. So since we can't do that yet, we have to just go forward and figure out, okay, we have this kind of sticky situation, how are we going to monitor it? And the questionable choice that was a Band-Aid solution then was, well, just stick Nginx in front of it, and then that'll route between the two APIs, and then we can monitor Nginx, and that's going to be amazing because reasons. We've got other stuff to do, but it turns out, you don't actually know what's going on. And for a while, for well over a year, it seemed like that was actually working in that we hadn't had any problems with it yet. But if we're going to be responsible and consider monitoring, before you run into some nasty Band-Aid situation, what kind of things should we actually be thinking about? You start out on the very basic level, you have services. Are the services that are supposed to be running actually up and running? And that's pretty easy to take care of. You stick a check for it in your Sensu or your Nagios or whatever, and that's great. But that wasn't the problem here. Obviously, the services were up and running, but they weren't responding. So you have to consider responsiveness. Again, responsiveness of maybe it's, is the network working? Is your API responding? Is your web service responding to requests? It's kind of a simple yes or no question that, yeah, when you add a new service to whatever it is that you're building, it's pretty easy to remember, yeah, we should check and make sure it's running and it's responding. On top of that, there's system-level metrics. There's stuff like, how much memory is the system using, the CPU usage, the disk space, all of that fun stuff, which is pretty easy to set up the thresholds for these, but it depends a lot on your application. For example, our Mongo servers are supposed to be using all of their memory, because that's how magical and web scale they are. We'd be slightly worried if they weren't using all of the memory that we have assigned for them. But if our web servers are using all of their memory, that's a bad thing. Something has gone terribly wrong in there. On top of that, then there's application metrics, which will depend even more on your domain knowledge to set up the thresholds for these. This could be stuff like, how much time is your database spending in wait for a read lock or for a write lock? What percentage of your web requests are returning errors instead of OKs? What's the API response time? Do you have some calls that are sitting around for a minute, not doing anything? These kind of things usually take a little iteration to get the thresholds right. And the important thing here is to make sure that you actually do the work to set the thresholds, to get them to work out, because you don't want to find yourself in a situation where you're like, oh, that check. Yeah, that's red, we know that's red, but it's fine. We know it's, just ignore it, it's fine. Also consider, if you have monitoring that's been around for a while, if it's old, will it scale over time as your site grows, as the stuff that it's trying to monitor grows? It was mentioned earlier, you have to make sure that your monitoring is more responsive than what's trying to be monitored. You need to make sure that it can keep up. We ran into an issue where we had a bunch of servers and each of them ran like 50 or so queues. One time, all of those servers went down. There was about 20 of them, 50 queues, do the math. There was a Sensu check for each one. They all started alerting, and Sensu just said, no, I'm sorry, I want to do this, I can't handle it right now. Because the instance just wasn't big enough to deal with every single one of those. So, aggregates are your friends, maybe rebuild the box, beef it up a little bit. You also might consider actually load testing your monitoring. And you could do this either in a pre-production environment or as part of your regular load testing, which hopefully you're doing, to make sure that your monitoring system can keep up, to make sure that it is responding and behaving the way that you expect it to. So maybe you can see, oh, we saw this fail in our load test, but we didn't get alerted for it. Maybe we should fix that before it goes live. So that can help you make sure that as your site grows or your company grows or your number of services, microservices grow, that you'll be able to actually keep up and monitor all of them and monitor them effectively. Throughout all of this, it's really important to remember that monitoring is way more important than something that can be just tossed over the wall at the last minute to the ops team and just, yeah, worked fine in dev, ops problem now. I told the story at Monitorama in Berlin where I found myself on a team that was getting yelled at, and they're like, that service went down, why didn't you know? And we said, well, what service? We didn't even know that the service existed. I can't monitor something if I don't know that it is a thing that exists in the world. So silos are bad, teamwork is good. If ops and devs are working together and DevOpsing from the beginning, they can make sure that people are considering how you're going to monitor these things all throughout the product development, whatever life cycle. Maybe somebody could have said, so having these two APIs on the same server is a little weird. What would happen if we split them up, and could we monitor them more effectively that way? Or you could work with the developers to say, okay, what does it mean for this service to be working properly? What is it going to look like when it breaks? And so we have all of these nice things that we've talked about, working together, doing this from the beginning, not having monitoring be a last-minute thing or a reactive response to something going wrong, but considering it throughout so that we can, not blip. Thank you. Question.
In the situation you're talking about with the two APIs sharing the server, how do you make sure that you're monitoring the right parts of whatever is being caused by API 1 versus whatever is being caused by API 2? I mean, obviously sharing isn't the ideal situation, but how do you even split up which one is causing what problems?
So the question was, how do we determine if API 1 and API 2 are sharing the same server? How do we figure out which one is causing problems? And the answer was, we were able to tell a little bit because one of them was Tornado, one of them was Apache, so we could say, oh, Apache's using all of the system memory, it's probably there. But really the answer was we couldn't, and that's why we ended up getting rid of most of API 2, simply so it was a bad idea from the beginning. Don't rewrite your API from scratch unless you've thought it through. Yeah. Awesome. Thank you.